A turboshaft engine is a form of gas turbine which is optimized to produce shaft power rather than jet thrust. In concept, turboshaft engines are very similar to turbojets, with additional turbine expansion to extract heat energy from the exhaust and convert it into output shaft power. They are even more similar to turboprops, with only minor differences, and a single engine is often sold in both forms. Turboshaft engines are commonly used in applications that require a sustained high power output, high reliability, small size, and light weight. These include helicopters, auxiliary power units, boats and ships, tanks, hovercraft, and stationary equipment. Overview: a turboshaft engine may be made up of two major parts assemblies, the gas generator and the power section. The gas generator consists of the compressor, combustion chambers with igniters and fuel nozzles, and one or more stages of turbine. The power section consists of additional stages of turbines, a gear reduction system, and the shaft output. The gas generator creates the hot expanding gases to drive the power section. Depending on the design, the engine accessories may be driven either by the gas generator or by the power section. In most designs, the gas generator and power section are mechanically separate so they can each rotate at different speeds appropriate for the conditions, referred to as a free power turbine. A free power turbine can be an extremely useful design feature for vehicles, as it allows the design to forego the weight and cost of complex multiple ratio transmissions and clutches. The general layout of a turboshaft is similar to that of a turboprop. The main difference is a turboprop is structurally designed to support the loads created by a rotating propeller, as the propeller is not attached to anything but the engine itself. In contrast, turboshaft engines usually drive a transmission which is not structurally attached to the engine. The transmission is attached to the vehicle structure and supports the loads created instead of the engine. In practice, though, many of the same engines are built in both turboprop and turboshaft versions, with only minor differences. An unusual example of the turboshaft principle is the Pratt & Whitney F135PW600 turbofan engine for the STOVL F35B. In conventional mode it operates as a turbofan, but when powering the lift fan, it switches partially to turboshaft mode to send 29,000 horsepower forward through a shaft and partially to turbofan mode to continue to send thrust to the main engine's fan and rear nozzle. Large helicopters use 2 or 3 turboshaft engines for redundancy. The Mi-26 uses 2 Lotareve D136 at 11,400 horsepower each, while the Sikorsky CH-53E Super Stallion uses 3 General Electric T-64 at 4,380 horsepower each. Early turboshaft engines were adaptations of turboprop engines, delivering power through a shaft driven directly from the gas generator shafts, via a reduction gearbox. Examples of direct-drive turboshafts include marinized or industrial Rolls-Royce Dart engines. History: the first examples of a gas turbine engine design ever considered for armored fighting vehicles, the BMW 003-based GT101, were tested in Nazi Germany's Panther tanks in mid-1944. The first true turboshaft engine for helicopters was built by the French engine firm Turbomeka, led by the founder, Joseph Szydlewski. In 1948, they built the first French-designed turbine engine, the 100 SHP 782. Originally conceived as an auxiliary power unit, it was soon adapted to aircraft propulsion, and found a niche as a power plant for turboshaft-driven helicopters in the 1950s. In 1950, this work was used to develop the larger 280 SHP Archist, which was widely used on the or copyright Rosparty Alouette and other helicopters. The U.S. Army operates the M1 Abrams tank. Designed and built in the late 1970s, this tank makes use of a gas turbine engine compared to most tanks using reciprocating diesels. The engine has considerably fewer parts, mechanically is very reliable and reduced exterior noise and runs on virtually any fuel. Gasoline, diesel fuel, aviation fuels. See also. References: Warwick, Graham. F-35B, the STOVL Challenges Aviation Week and Space Technology, December 9, 2011. Accessed, April 10, 2014. Me26 halofaz.org, September 21, 1999. Accessed, April 10, 2014. About the GET64BGA Aeroweb, May 17, 2012. Accessed, April 10, 2014. K. Anthony, German Jet Engine and Gas Turbine Development 1930–1945, Airlife Publishing, 2002, external links, Wikibooks, Jet Propulsion.